So guys, how are you? Make sure you subscribe to this channel. I'm going to be very brief and very fast. How to calculate the mode in grouped data. First of all, you need to know the formula of finding the mode, and I'm giving you the formula now. I'm saying the mode in grouped data is calculated by the lower boundary of the model class. Okay, lower boundary of the model class plus d1 over d1 plus d2i. Okay, this is the formula. And what does this mean? The lower boundary of the model class plus the model frequency minus the frequency immediately above it over again the model frequency minus the frequency immediately above it plus the model frequency minus the frequency immediately below it, and this I implies the class interval. Okay, so what do we mean by that? If you're from the lower boundary of the model class in this set of data, I forgot to indicate the frequencies. Here is 2, here is 4, here is 10, here is 12, here is 8, and here is 6. So the lower boundary of the model class, if you look at this data, obviously the model class is going to be in the class with the highest. The model class is the class with the highest frequency. Of course, it is 16 to 20. This range is where the mode is going to be. All right, it is between 16 and 20. Okay, so the lower boundary of the model class is going to be, if you look at the lower boundary, is going to be this 16 minus 0.5. So the lower boundary obviously is going to be 15.5. All right, plus d1, which we said is the frequency, model frequency minus the frequency immediately above it. So it's going to be 12, which is the model frequency, minus frequency immediately above it, that is 10. All right, over the d1, which is again is 12 minus 10, plus d2 is the model frequency minus frequency immediately below it now. So it is going to be 12 minus the frequency immediately below 12 is 8. So it's minus 8. And then we have the I, which is the class interval. If you look at this one, the class interval is calculated by upper boundary minus the lower boundary of any given class. So let's say, for example, the model class here, the upper boundary here of the model class is 20.5. So it's going to be 20.5 minus the lower boundary, okay, which is 16.5 minus 0.5, which is 15.5, and therefore the class interval is going to be 5. So here is 5. So the mode is going to be 15.5 plus 12 minus 10 is going to be 2, divided by 12 minus 10 is 2, plus 12 minus 8 is 4. Okay, 5. So this is going to be 15.5 plus 2 divided by 6 to 5, which is going to be 15.5 plus 10 over 6, which is going to be 17.1 17. So you see, the mode is 17.17. So that is the mode and how to calculate the mode. You just have to know the formula, which is the lower boundary of the modal class, the lower boundary of the modal class plus D1 is the modal frequency minus frequency immediately above it. You repeat the same here. Then D2 is the modal frequency minus frequency immediately below it, and then the class interval is always the upper limit boundary minus the lower limit boundary. Okay, which is 20. I have told you how to determine the upper limit boundary and the lower limit boundary. So after getting the class interval to be 5, then you come and substitute here very fast, and you get your answer to be 17.17. That is the mode. All right, thank you very much, and remember to subscribe to my channel. Thank you.